absolute value and reciprocal function. So absolute value, how we defined absolute value? So absolute value of any real number a can be defined as y equals to absolute value of a is it stay as it is if it is greater than 0, greater than or equal to 0. We need to take reciprocal, means opposite, if it is less than 0, and this is called piecewise function. So that concept will help you when we solving absolute value equation algebraically. To solve each absolute value equation algebraically, we have to write down piecewise function first. So absolute value of x minus 5, it can be positive or it can be negative. So we have two cases here. So case 1 and case 2. Case 1 is for positive. If x minus 5 is greater than or equal to 0, that means x is greater than or equal to 5. Case 2, if x minus 5 is less than 0, that means the value of x must be less than positive 5. Write equation, first of all it is positive, so write as it is because of positive. But if it is negative, then put negative sign outside. So first write piecewise function and then solve it. Solve as like linear equation. So combine x term. So x minus 3x equals to 4 plus 5 minus 2x equals to 9. So x equals to negative 9 by 2 minus x plus 5 equals to 3x plus 4. Combine like terms, so negative x, negative 3x, 4 minus 5, negative 1, so x equals to 1/4. Then we have to verify the answer. We have to check to make sure it is extraneous solution or not. For verification part, we have to plug the value in left side of the equation and right side of the equation. So the left side is x minus 5 absolute value, and right side is 3x plus 4, negative 9 by 2 minus 5, multiply top and bottom by 2, so negative 19 over 2. If we take absolute value, it becomes positive. Right hand side, negative 27 over 2, multiply top and bottom by 2, which is negative 19 over 2. Here we can see left hand side is not equals to right hand side. Therefore x equals to negative 9 by 2 is extraneous solution. Substitute value 1/4 here. So 1/4 minus 5, which is 1/4 minus 20 over 4. it becomes negative 19 over 4, which is positive 19 over 4. 3 times 1/4 plus 4th. So 3 plus per 4th. So 3 plus 4, 16 over 4, which is 19 over 4. Both have a same value, positive. So left side equals to right hand side. So finally, you can write your answer. Solution is x equals to 1/4 and x equals to negative 9/2 is extraneous solution. In second equation, same thing we can do here. So case 1, x square minus 2x is greater than 0. In case 2, x square minus 2x is less than 0. So if positive, then it stay as it is. If negative, then you have to take opposite. Take x one left hand side. To solve a quadratic equation, we know that we can use factoring method, completing square method, or quadratic formula. Here factor is not possible, so we can use quadratic formula. So the value of a, which is 1, b is negative 2, and c is negative 1. To solve this equation, use quadratic formula. Substitute all the values, so negative and negative, negative 2 square minus 4, 1 and minus 1. If you solve, it comes 2 plus or minus 8 over 2. 8 can be simplified. So 2 plus or minus 2 root 2 over 2. So your x1 is, take a 2 common. You can simplify more. Either you divide both by 2. So x equals to 1 plus or minus root 2. So here we have a two different value of x, 1 plus root 2. x2 is 1 minus root 2. If we take approximately value of 1 square root, so which is 1.4. So x1 equals to 2.4. Here we need value in decimal to find verification, minus 0.4. Okay, then we have to check, otherwise we can see what's the condition. You can substitute this value in condition as well, or so when you substitute this value in for verification part, you have to verify, so you have to substitute both value in left side and right hand side. So it does satisfy the condition, which is x square minus 2x is greater than or equal to 0. Therefore it is a solution. In the other case, negative x square plus 2x minus 1 equal to 0. To remove negative sign, with first term multiply all term by negative 1. Make a factor, it is factorable. It has a two equal values, so x equals to 1. and if you plug value, so x equals to 1 does satisfy the condition x square minus 2x is less than 0. Therefore, x equals to 1 is also a solution. So finally, we got 3 solutions. Therefore, the solution are x equals to 1 plus or minus root 2 and x equals to 1. In this equation, it says for each function, in first answer we are writing reciprocal function, then domain of the function and its reciprocal function domain, range, and reciprocal function range. Let me explain question 1. So you have y equals to x plus 4. What is the reciprocal? So the reciprocal is y equals to 1 over x plus 4. Take inverse. So the domain of base graph, you know this is equation, so domain is negative infinite to positive infinite, all real number possible. But the domain of the reciprocal, we cannot accept x equal to 0. So you say x such that x belongs to R except x equals to negative 4. Except negative 4, all value possible for the domain because it makes denominator 0. If we're talking about a range of the base graph, so range is possible values of y. For the linear, it's negative infinite to positive infinite. But for the reciprocal graph range, so y cannot be 0. So except 0, you can say y such that y belongs to R. Y cannot be 0 because if you plug y equal to 0, supposed to be what happened, let's see, 0 equals to 1 over x plus 4. Take a cross multiplication, so 0 equals to 1. That's not true. So that's the reason y equal to 0, it's the restriction. For second question, you can do same way. And the reciprocal of this function, which is x plus 2, x minus 2. This is quadratic. So to find the domain, so for quadratic, domain is all real numbers. To find the range, you need to know vertex. So what is the vertex? So vertex is 0, negative 4. So y value of the vertex always makes effect on range. So the graph is face up, so it has minimum value. So minimum value is negative 4 and maximum value is infinite, positive. So that's a domain and range of the base graph. For the reciprocal function graph, the domain only, you can write x is such that all real numbers except x cannot be plus or minus 2, because x equals to plus 2 and minus 2 makes denominator 0, which is makes expression undefined. For the range, y is such that y belongs to R, y cannot be 0. To sketch the graph of reciprocal function and base graph, it says find out asymptotes, invariant points, and intercept. So we know what is asymptotes. There are two types of asymptote we have to learn here: vertical asymptote and horizontal asymptote. Basically, asymptote is the line where the graph is approach but never cross it. Okay, so f of x equals to 16, which is base graph, which is base function or parent function, you can say. The reciprocal is y equals to x minus 16. To find out asymptotes, we need to know there are two asymptotes: vertical asymptote and horizontal asymptote. To find vertical asymptote, set denominator equal to 0. So x minus 16 equal to 0. So x equals to 16, which is your VA. To find horizontal asymptote, we need to see degree of the top polynomial and the degree of bottom polynomial. So degree of the top polynomial is the less than of degree of bottom polynomial. In that case, y equal to 0. Y equal to 0, basically x-axis. Now to find invariant point, so invariant points is points which is unchanged point after transformation has been done. To find invariant point, always set y equals to plus or minus 1. So we have a reciprocal function x plus 16. Take y equals to positive 1 and y equals to negative 1 to find value of x. So 1 equals to x plus 16, cross multiplication. So x equals to minus, oh, I made a mistake, not a positive 16, negative 16, sorry. So it comes 17. Take negative 1, so 1 over x minus 16. Negative x plus 16 equals to 1. So x equals to 15. So we got two invariant point, x equals to 17 when y equals to 1. So 17 and 1. And x equals to 15 when y equals to negative 1. And then what else? Invariant point, intercepts. Yeah. To find x-intercept and y-intercept, we know what to do. To find x-intercept, set y equal to 0. So y equals to 1 over x minus 16. 0 equals to 1 over x minus 16. Take cross multiplication. 0 equals to 1. That's not true. So x-intercept is none because of it is horizontal asymptote. Means graph never crossed to x-axis. To find y-intercept, set x equal to 0 in reciprocal function graph. So y equals to 0 minus 16. So y equals to negative 1 over 16. So the y-intercept is 0 and negative 1 over 16. So we have all the information to sketch the graph. So first we have to sketch vertical asymptote. Vertical asymptote is x equals to 16. So we can think value like 2, 4, 6, 8, 10, 12, 14, 16, -2, -4, -6, like that. So x equals to 16. So this is your vertical asymptote. If possible, then use different color pen. So that would be better. So this is your VA. Then you need a horizontal asymptote, which is x-axis. Remember, your graph must be approach both line but never cross it. X like horizontal asymptote and vertical asymptote. Where the graph goes, for that we need to plug values of invariant point. So what was the invariant point? So if you notice, invariant point was 17 and 1 and 15 and -1. So 17 and 1, where it goes? So 17, 1, this is 18, so 71 it should be here, and 15, -1, it should be here. So we know where the curve goes. So then after, remember, we making curve which is approach the asymptote but never cross it. And one another goes here. If you wanna make exact graph, we can pick some more values. This is the graph of that. Same thing is asking here, but it is quadratic. So let me first find out the first asymptote. So vertical asymptote of reciprocal function. So first of all, reciprocal function is y over x square minus 16. So VA is x square minus 16 equal to 0. Make a factor, so x minus 4x plus 4 equal to 0. So x equals to positive 4 and x equals to -4. So we have a two vertical asymptote, x equals to positive 4 and -4. If we talking about horizontal asymptote, so the degree of top is less than degree of bottom, so y equal to 0, which is basically x-axis. For the invariant point, as we know, we have to set y equal to plus or minus 1 in reciprocal function. So your reciprocal function is y equals to 1 over set y equals to positive 1, y equals to -1. So 1 equals to, take cross multiplication. So x equals to plus or minus root 17, which is x equals to plus or minus 4.1 or 4.2. We just approximately answer we need. For -1, so minus x square plus 16 equals to 1. Negative x square equals to -15. So x square equals to 15 plus or minus 15 plus or minus 3.8 or 3.9. So here we have a 4 invariant point. 4.2, positive 1, negative 4.2, positive 1, then 3.9 and negative 1, negative 3.9 and negative 1. For x-intercept, we know for the x-intercept it's none because of it is horizontal asymptote. For the y-intercept, which is 0, negative 1 over 16, you set x equal to 0. So we have enough values. We need vertical asymptote, so we have a x equals to positive 4 and negative 4. Then we need invariant point. So the invariant point we have 4 invariant point we got, which is 4.1 and 1, negative 4.1 and 1, 3.9 negative 1. Okay, we also need vertex. So the vertex of parabola, which is you have a y equals to minus 16, okay, let's be plot first. So we need vertical asymptote positive 4 and negative 4. We can use different color pen. This is your vertical asymptote for positive 4. Negative 4. Then horizontal asymptote okay, so the vertex of original graph, which is 0, negative 16. So the vertex of this is for base graph, vertex of reciprocal function graph is 0, negative 1 over 16. Just a y coordinate reciprocal. So let me plot other point. So 0 vertex 0, negative 16. It's very close. It's right here. Let me plot a point 4.1 and 1. 4.1 and 1. It goes here. Negative 4.1 and 1. It goes here. 3.9 and negative 1. 3.9 and negative 1. It should be here. And negative, it should be here. So we understood where the graph goes. And so the one part of the graph, it goes here. Second goes here. Then third one goes so this way we can get the graph of reciprocal function graph. Okay, in this question we are finding vertical asymptote before find vertical asymptote, we need to simplify first. So simplify first. So cross out common factor if we have. So 1 over x minus 4. Now vertical asymptote, which is x equals to 4. Horizontal asymptote, so the degree of top is less than degree of the bottom, so y equal to 0 because n is less than d. Hole will be occur when we have a common factor on top and bottom. Right now we have, so you set common factor equal to 0, so x equals to -3. To find y, you substitute value, so -1 over 7. So the hole will be hole means discontinuity point. It is also called discontinuity point. To find y-intercept, set x equal to 0. So set x equal to 0. So y equals to 1 over 0 minus 4, -1 4. So your x-intercept is 0, -1/4 x-intercept. So set y equal to 0. It is possible. So set y equal to 0. So cross multiplication, so that's not true. So you write here none. Find VA here, set simplify. So x minus 2, x plus 2, x minus 2. Cross out common factor. So your VA is x equals to -2. Horizontal is y equal to 0 because degree of top is less than degree of bottom. Hole will be occur, x plus 2 is common, so set x plus 2 equal to 0. So hole will be occur at 2 and 1/4. Y intercept comes 0 and half. X intercept is none.